Hello dear students, once again I welcome all the standard 9 students on this online classes. So previous classes what we have discussed Newton's first law of motion and inertia, and related to that one some examples also we have discussed which are given in your book. Yes, I hope all of you have understood that much. Yes, and what else we have discussed? The qualitative definitions of force, which is explained from Newton's first law of motions. Okay, you just go through it properly, and I hope all of you have understood up to this much. So today we will be going to discuss about mass and inertia. So without delaying, let's get started this one. Mass and inertia. Inertia, previous classes we have discussed. Yes, I hope all of you have understood that one also. But mass is familiar with us. Yes, so let us start this one. Everyday experience tells us that a given force produces different magnitudes of acceleration for different bodies. So two different bodies are there. In one body we have applied more force, and in another body we have applied less force. Which one will move a longer distance? Obviously the object where we have applied large amount of force, in that case it will move a longer distance. Or we can say that one, what we can say, magnitude of accelerations of both the bodies are different. So wherever we have applied the more force, in that case the more amount of accelerations we can found. But in other cases, yes, less acceleration we can find out. Yes, example, put a baseball and a bowling ball on the floor and give both of them a kick. Even if you cannot actually do this, the result is known. The baseball receives a noticeably large accelerations than the bowling ball. The two accelerations differ because the mass of the baseball differs from the mass of the bowling ball. Yes, so two different, other than this example also we can explain, and you can understand also from there also. So two objects are there which are having different masses, yes, but same amount of force we have applied to both the bodies. On which case it will move more distance, and on which case it will move less distance, you know that one. Yes, so what we can conclude there, a less massive baseball receives a greater accelerations than a more massive bowling ball when the same amount of force is applied to both. Obviously this one will happen. Then mass is an intrinsic characteristic of a body. That is, what is that intrinsic characteristic? Let us see. That is a characteristic that automatically comes with the existence of the body. Yes, that mass is the intrinsic or internal characteristic of a body. It is automatically comes into existence. Since the word mass is used generally, we should have some intuitive understanding of it being something that we can physically sense. We can say that the mass of a body is the characteristic that relates a force on the body to the resulting accelerations. Obviously, that mass is also responsible for the motion. If a huge object is present and we are applying a small force, is it possible that huge object will move? No, it is not possible. Yes or no? To move that huge object, we require more magnitude of force. Yes, so obviously mass is also dependent variable. Thus it can be concluded that more the mass, the more difficult is to move or change a body from rest or modify or stop the motions of a moving body. So exactly like that, if an object is in the state of rest, in that case also more amount of force is required to move. But if a huge object is moving, in that case also a huge amount of force is required to stop that one. Yes, since the resistance to motion is inertia, we can say that greater the mass, greater is the inertia. Therefore mass is directly proportional to inertia, hence mass is a measure of inertia only. Did you understand this one? So types of inertia and its examples as illustrations of the first law, inertia of rest. According to the law of inertia of rest, a body continues to be in the state of rest unless an unbalanced external force acts on it. Previous classes we have discussed about this one also. If an object is in the state of rest, it will remain in the state of rest only forever and ever until and unless an external unbalanced force is not acting on it. The following example illustrates the property of inertia of rest. Place a calculator or diary on a drawing sheet of paper kept on a table. Hold one edge of the sheet and pull it quickly. The paper will come off, leaving the calculator or diary undisturbed, that is, at the same positions. We can conclude that calculator or diary tends to remain at rest when the drawing paper sheet is removed. So because of inertia of rest only it is possible. Even if we will pull that drawing paper quickly, that calculator or the diary will not move anywhere. It will remain rest at the same positions only. Yes, this one is the example of inertia of rest. Next one, place a cardboard over a tumbler and place a coin over it as shown in figure 3.3. When a sudden jerk is given to the cardboard, it flies. That cardboard will fly, but not the coin. That coin will be falling down inside that tumbler only. It happens due to the fact that the coin does not share the motions of the cardboard due to the property of inertia only. This is happening like that only. Yes? This one you can try in your home also. Okay? So up to this much, I think all of you have understood. Okay? Thank you.